Yeah, we do number 54.
54, perfect pick. Make sure I copy the correct one. Limit as x approaches 0 from the right. 1 over x, do not forget parentheses here. 1 over arc tangent x. So limit as x approaches 0 from the right. 1 over x minus 1 over. I know this notation is confusing. Please remember this means the inverse tangent. Don't put tangent at the top because it has power -1. So that's the confusing part. Okay, perfect. Good. Step by step. Where is this going? Of course, you know from to 0. Now you have this graph in your mind. Where is this going? As x approaches 0 from the right. We graphed it many times.
Zero.
Okay. This should be on your mind forever, forever, forever.
Infinity.
Awesome. Now, as x approaches 0 from the right, where is arctangent? Please remember the graph. We graphed it many times. We graphed the graph of arctangent, which has two horizontal asymptotes, y equals pi over 2, y equals negative pi over 2. And it kind of looks like the cube root. No, not really. Something like this. So this is arctangent x. As x approaches 0 from the right, where is arctangent going? But it's 0, right? So as x approaches 0 from the right, arctangent gets closer and closer, closer and closer to 0. So this piece, just this piece, 0. Now I want this piece. It's like 1 over x. Probably that's what you meant. You already gave me the whole answer. So it's 1 over 0 from the right, which is 1 over 0 from the right is infinity. So which indeterminate case are we facing here?
Number 3.
Right?
Yeah.
Infinity minus infinity. Is that okay? Because it's minus. It's not a product. So we have infinity minus infinity. Good. So what do I do in this case? So I'm continuing here, jumping over this. Well, I have to find the least common denominator. There is nothing else I can do. That's my only hope. Can anyone give us the least common denominator of these two fractions?
X arctan x.
Yes, it. Good. Now remember, I have to multiply this by arctangent and multiply this by x, what it does not have. So the numerator is arctangent minus x. I'd have to try again because I don't know what to do with this unless it's 0 over 0 or infinity over infinity, I cannot jump ahead and say, oh, let's differentiate. No, I cannot do that. I have to check, and if it's not one of these two, I can continue with L'Hopital's rule. I don't know what it is, but if it's not one or the other, I can continue. We already know that 0 from the right, arctangent approaches 0. 0 from the right, x approaches 0. 0 minus 0, the top is 0. Promising. Of course, this is 0 and this is 0. 0. So I do have one of the two L'Hopital's rules cases, so I can go ahead and differentiate. Good. So I copy limit, Sx approaches 0 from the right. And remember how we differentiate. We never do this unless it's a limit, it's a ratio, and 0 over 0 or infinity over infinity. Limit, ratio, and one of the two. Good. Arctangent prime. Can anyone give us arctangent prime? And then I have minus 1 at the top. And then we'll differentiate the product. The product has to be differentiated as a product. Can anyone give us arctangent prime?
It's 1, isn't it 1 over
1 plus
is it minus or plus x squared?
x squared. That's it. Perfect. So now I'm going to multiply here. I'll use the product rule. First function prime is 1. Arctangent x plus the first function times arctangent x prime 1 plus 1 over x squared. X over 1 plus x squared. Good. Okay. So now let's see what we have. I can continue. I have to check again. So now I'm here. And that's my 7. Okay. So when I plug in 0 here, I still get 1 minus 1. This is 0 and this is 0. Still 0 over 0. I have to continue. I apply L'Hopital's rule the second time. As long as I have 0 over 0 or infinity over infinity, I have to apply it as many times as I need. Because I can. Okay, now this will go away. This is 1 plus x squared. I prefer that. 1 plus x squared to negative 1. It's easier to differentiate versus a ratio, but it's up to you. This is my preference. So I have negative. I have 1 plus x squared to negative 2 times the inner function prime. Okay. Now, the denominator. 1 plus 1 over x squared plus, and this is a mess. I have to differentiate this as a quotient. I have no choice. So 1 plus x squared squared. The top prime is 1. 1 plus x squared minus the top times the denominator prime. It may end at some point in time tonight. Who knows? Maybe, maybe not. Maybe we'll spend the night here on this. I'm just kidding. Okay. The numerator is negative 2x over 1 plus x squared squared. And this still goes to 0 when x approaches 0. Let's see. Maybe this is not 0 and then we're done. And the answer is 0. Maybe. We hope. Okay. So 1 over 1 plus x squared. This is negative 2x squared plus x squared. So negative 2x squared plus x squared and plus 1. So I have negative x squared and plus 1. 1 plus x squared squared. I will not continue to differentiate till I simplify this as much as I can. Okay, so one more time I copied this. This was negative 2x squared plus x squared is negative x squared, and then I have positive 1, so negative x squared and positive 1. Okay, I will factor out 1 plus x squared. I'm sorry, I will find the least common denominator is 1 plus x squared squared. That's why we study algebra first before calculus. See? What can we do without algebra here? So the least common denominator is 1 plus x squared squared. This one needs a 1 plus x squared. Okay, 1 plus x squared minus x squared and plus 1. Gee whiz, I have my hopes were met. The numerator goes to 0, but the denominator goes to 2. Yay! 0 over 2 is 0. So I have to try again and see what it is. So this is a 2, and this is 1. So this approaches 2 over 1, and this approaches 0. And 0 over 2, I cannot apply anything else. 0 over 2 is 0. So that was a long one. And the powers will be kind of like the same. Okay. So finally, we reach the powers. So let's choose any power you want. Probably, I'm assuming 58 through 70, they're all powers. Yeah, of course. So all powers from 57 all the way through 70.
We do 62.
Yes, let's take a look. 62. This one. Okay, perfect. 62. Watch me copy the right problem, please, because I have these devices in front of me. E to the x plus 10x and everything raised to 1 over x. Okay, perfect. Hold on to your seats. These are the longest. Some of them are long, some of them are not that long, but it depends. Okay. Now we have to plug it in. So let's start with the power. As x approaches infinity, where is this going?
0.
Perfect. As x approaches infinity, where is this going? And where is this going? And where is this going?
Infinity.
That's it. Which indeterminate case are we facing here?
Infinity to the power 0.
That's it. Do not conclude anything. Anything can happen. So this is a power. We like ratios, we like products, even infinity minus infinity, but power is not that much. Okay. So now, look at this function and tell me what type of situation we have here. This is a function, and this is a function. Have we ever seen something like this? A function to a function? And how did we handle it? What did we do?
Take the natural log.
Yes! Thank you. You didn't see me? I raised my hand to the sky. That's it. That's the way we have to handle this. So we're going to denote by y. So step 1, e to the x plus 10x raised to 1 over x. In step 2, I'm not going to ask because you already told me. Natural log y equals 1 over x natural log e to the x plus 10x. Okay. In step 3, apply, that's not good anymore. Apply limit, this limit that I have in the problem, as x approaches infinity to both sides. You can say, wait a minute. Fine, you're applying an operator to both sides, but you're not going to fool me. You're not asked to find the limit of natural log. You're asked to find the limit of this, of y. Why are you applying the limit to natural log? This is not the question. You will see where I'm going in a minute. So we have limit as x approaches infinity from natural log y equals limit as x approaches infinity, and I'm going to write it as natural log e to the x plus 10x, everything over x. So yes, we're not asked to find the limit of the natural log, but for now, bear with me. Okay, what are we doing next? I have a limit, I have a ratio, what am I checking?
We want to check if we can use the Lepich's rule.
Good. So obviously this goes to infinity. Where is this going? You already told me when we analyzed this that this approaches infinity. But where is natural log of infinity going?
Infinity?
Yes, because we know the graph of natural log. Please carve these in stone, please. It will make your life so much easier. Good, yay! So for now, I have infinity over infinity. I'm going to apply L'Hopital's rule. I'll do the easy part, and you do the difficult part. Can anyone help with the derivative of this?
Um, 1 over EX plus 10x times e to the x plus 10.
Excellent, awesome. Good, I'm going to rearrange it. Excellent. What do I do next?
Log in infinity.
Good. Where is the top going? Awesome.
Infinity.
And the denominator?
Infinity.
Good. Let's do it again. Can anyone give us a derivative of the top?
E to the x.
Good. Can anyone give us a derivative of the denominator?
E to the x plus 10.
Awesome. Still infinity over infinity. Okay, one more step. Looks very promising. Still infinity over infinity. So can anyone differentiate the top?
E to the x.
Can anyone differentiate the denominator?
E to the x.
Can anyone apply the limit and drop the limit operator and then tell us the answer?
So 1. 1.
Awesome. Here's step 4. I copy the beginning and I copy the end. Copy beginning plus end of step 3. We talked about in chapter 2, under continuity, there was a theorem in there called it's not called that. I like to call it swapping. Swapping of operators. Let me remind you that we used it, but we didn't talk about it. So when we said the limit of the square root of a function, Sx approaches a, we said we can swap, if the function is continuous, we can swap the operators, put the square root outside and the limit inside. I guarantee you that this is a continuous function and also this is a continuous function. I am going to swap the operators. In step 5, swap the operators. So I'm going to put natural log outside and the limit of y as x approaches infinity equals 1. And now we have several ways. Natural log of what is 1? Or e to the first power equals this. So limit of y, which was e to the x plus 10x, everything to 1 over x. Can anyone give us the answer?
1.
No, because natural log 1 is not 1.
E to the first power.
E. Natural log e is 1. So then the limit, thank you so much, of y is e. So we're going to work on other problems right now, of course.